light. So a plane flies 50 kilometers with a bearing of 316 degrees clockwise from north. That's a little different than what we usually think of with bearings, but it is saying that right here at this location, from the northern direction, it is going 316 degrees, so all the way around clockwise, which is how they give you that little angle of 44. So just kind of making a triangle here. Let's go over a little more. So here is our northern direction. So really this whole angle there is 316 degrees based off of the information that they're giving us. The rest of it, because it's 360 the whole way around, is 44 degrees. Which makes the inside angle 46, which is what I just had labeled. So that inside angle is 46 degrees. And then the other information that's given for us, we have this distance here is 720 kilometers, and this distance here is 500. And the goal is for us to find the bearing of, I think this is Elflin. And again, the bearing that they're kind of talking about goes all the way around. So it starts at the north, and we need to find that information there. So the angle that kind of pulls us all the way around to the other edge. So any suggestions about how you could start, like how to start number 43? We have two sides, we have an angle inside. Our goal is to work with this angle up above and then try and create a bearing from that angle. So how could you use the law of science to find that angle inside the triangle? So how will we set up the law of science? Like what pieces do we have to make proportions, ratios? Jacob?
We have the angle A, which is the bottom right.
Yeah, so we have the bottom right, and across from it we have its side distance of 720, and this is 46 degrees, so we'll take the sine of 46. What else can you find, Jacob?
You can find angle B.
Yeah, so he's called this B over here, and he called this A. So we can find angle B because we have the opposite side of 500. So we would take 500 and divide it by the sine of B. And we need to find that angle so that we can then find the angle on the upper part of the triangle. So you have to find the other one in order to get there. So when you're cross multiplying, we're taking 500 times the sine of 46. We would be dividing by 720. That's going to be equal to the sine of angle B. So in the calculator, we need to use the inverse sine because we're finding the angle, and you're taking the inverse sine of all of this stuff right here. So 500 sine 46 degrees divided by 720. And Jake, what did you get for that?
I got 30 degrees.
Yeah, it's about 30 degrees. I think I have 29.97. We'll say approximately 30 degrees. So this here is a 30-degree angle. So that means then the one on the top, if I have a 30 and a 46, that makes 76. And if we subtract that from 180, Jake, that makes about
60. No. My bad. 104.
Yeah, that makes about 104 degrees. So the bearing, based off the information from the book, it says the bearing goes from the north and then it moves in the clockwise direction until you get to the side or the distance that you're traveling, the angle that you would be traveling. So we have the 104 degree angle. This up here would be a 90 degree angle. So we need to take the 104 degrees. We need to add 90 degrees with it. And then we also need this little angle here. Anybody know what that little angle would be? Sean?
46.
Yeah, it's 46 degrees because alternate interior angles, this angle and that angle, are congruent. So on top of the 104 and the 90 degrees, we need to add the 46. And that gets us that entire angle to give us the bearing based off of the directions from the book or the definition from the book. And when you add those together, it is about 240. Is that about 240? Yeah. So about 240 degrees. And that would be the bearing from the north. Questions on that? So using alternate interior angles, using the law of sine to find the other bottom angle, the other base angle there. And then trying to kind of interpret what their bearing is representing in this problem. Questions? I can show you my diagram for 45. So 45 also use the alternate interior angles to help you find the information. So for 45, the angle of 70 was given, and then I think the bearing was given as well. Yeah, the 65 degrees. So this angle here, that 65 degree angle, was also given. So using alternate interior angles, the bearing of 65 north going east was given. Alternate interior angles means then that here's the 70 degree angle that they gave you on the other side that's also 65 degrees. And then that enabled me to find the inside angle being 15. So they gave you two angles on the right side of that triangle. And then I used the law of sine. So I took the A over the sine of 15 degrees, set that equal to 30 because they give you 30 kilometers over the sine of 30, and then that gave me the 15.53 kilometers. And then I did the same thing with the other side as well. So the tricky part with 45 was trying to get the angle inside, and that would be using the alternate interior angles. Fact again. To get the outside 65 from the bearing, the inside 65, so that you could find that 15 degree angle. Questions? So today we're going to draw some triangles in your packet. I think it's page 7. So if you find page 7 in the packet, there's a worksheet with 6 different sets of values, 2 sides and an angle, that we are going to use to help create a triangle. So if you get your ruler, your compass, and actually protractor, not compass. And if you place your sheet of paper in a horizontal, we're going to try and create 2 triangles on the one piece of paper. So if you go horizontally, you'll be able to create 2 triangles, hopefully. If not, I got lots of scratch paper. So if you look at number 1, the goal of this says we're going to construct triangles based off the information using just a ruler and a protractor. That's all we need. And we're going to see if we can try and create triangles from the side, and angle that you're given. And there's 6 different problems, so we'll try and make 6 different triangles. When you start, the first thing you need to do is put a point on the left of your page, and we're going to call that the location of angle A. And then you're going to make pretty much like the base of your triangle. So from angle A, just draw a line Try and get it as straight as you can. And it doesn't matter how long you make it because we don't know the length of that side. You're just making the base of the triangle. So I am going to do problem number 1 with you, where it says angle A is 25 degrees. And then it tells you side A is 3 centimeters and side C is 10 centimeters. So this is problem number 1 from the worksheet. So when you take your protractor, you're going to line up the middle line where it kind of makes that perpendicular angle with the baseline and the angle that you created, or the point that you have created on the left side. So you're taking the horizontal line on the protractor, you're lining that up with the horizontal line you made, and you're putting the perpendicular angle pretty much in the middle of the point. And then we're measuring a 25-degree angle. So if you start on the right, because that's where your horizontal line is connecting with the protractor, we're going up to where it says 25 degrees, and you're going to put a little tick mark at 25 degrees. So I got a little tick mark there. And then using side C, so angle C is going to be somewhere over here. I'm not really sure where yet. But this is going to be the length of side C that connects with A. Because it can't be side A must be across from angle A. So the other side is going to connect with this angle, and that is 10 centimeters. So I'm going to measure a side length of 10 centimeters using the tick mark that I just created as well. So starting at the point for the angle, using the ruler. Sorry, don't have a centimeter guide? Yeah, make sure it has centimeters on it. I should have taken out the other ones.
So you want us to make side A?
So we are making side C because side C is going to connect with angle A. So side C is 10 centimeters. So I have my ruler starting in the point for A and then connecting with the angle that I just made, that little tick mark for the 25-degree angle, and then I'm making a length of 10 centimeters. And that's going to make angle B. So this distance is side C, which is 10 centimeters. So using the other side that you're given, the length of side A, which has to be across from angle A, is 3 centimeters. So if you go up to angle B, again put your ruler at angle B, you need to rotate your ruler to see where 3 centimeters connects with your baseline. So if I'm measuring 3 centimeters and I'm trying to make a triangle, so I'm just going to rotate my ruler and see if 3 centimeters would ever connect with the baseline of my triangle. And it doesn't.
It's not a triangle.
It's not a triangle. Right here would be 3 centimeters. I'm going to draw it just down. And you can see that it's too short to connect with the baseline. The shortest distance is always a straight vertical path or perpendicular path to get to a line. So here is side A, which is 3 centimeters. So the last thing that we are going to do is make a comparison, because this comparison then will help us decide what is happening with the sides of the triangle and why it's not making a triangle. So we're going to compare A and C. So A is across from the angle. C is the other side. And obviously A is less than C. So we have no triangle created. The other thing that I'd like you to calculate is the height of the triangle. And to find the height of the triangle, this line right here, we would take C times the sine of angle A. So we're taking 10 times the sine of 25 degrees. Anybody have their calculator out? Hannah? 4.3? Is that what you said? 4.2? So again, because the A is less than H, the height of the triangle, that's also the other condition why a triangle is not created. So in this case, side-side angle doesn't work because the height is bigger than the side of A, but also side C is too long for it to make a triangle with the side A. So if you look at number 2, your goal is to kind of go through that same information. Start with a point, so start with A on the left side of your page, draw a baseline, and then from that baseline and point for angle A, you're going to use the next angle value and the measurements that you're given. And see like how many you can work through. You might not get through all of them. So I'm going to give you about 10 minutes. You might not get through all of them in 10 minutes, but I want us to have enough time to kind of make sure we can summarize this information so we know why a triangle is created or why a triangle is not created. So make sure you're kind of comparing your side across from the angle, which is side A, to the other side.